When you think about running video to a screen, you're usually thinking, what, 3 feet of cable? Maybe 10 feet?
Yeah, just a standard copper cable you'd have at your desk.
Exactly. But today, we're doing a deep dive into a piece of specialized infrastructure that just, well, it laughs at those distance limits. And it's built to take a serious beating.
We're looking at the Kramer CRS Plug'n'View DP-164. It's a monster of an active optical DisplayPort cable.
And the version we're focused on is 164 feet long.
Right. And it's available up to 100 meters, which is over 300 feet. The price today is about $950.
So that price tag alone tells you, this is not consumer tech.
Not even close.
So our mission here is to really get into the extreme engineering that's required to push massive amounts of data over that kind of distance without a single failure.
And the key phrase from the source is that it's designed for the harshest use. Those two words really drive every single design choice here.
Okay, so what defines extreme in terms of performance?
Well, over that entire 164-foot run, the cable guarantees up to 8K resolution at 60 hertz.
8K at 60.
Yeah. And to put that into perspective, that needs a sustained data transfer rate of 32 gigabits per second.
And if you tried to push that much data through a normal copper cable that long, what would you get?
You'd get static, if you were lucky.
Right.
Most likely just nothing at all.
So if copper isn't an option, that means we have to use light, which is where the active optical cable part comes in, right?
Exactly. This cable's a hybrid. It has these tiny glass fiber strands inside for the high-speed light transmission, but it also still has copper wires.
What are the copper wires for, then?
They handle the slower speed communication and, crucially, the power transfer. It's that blend of materials that makes it all work.
Right, the active part. So that means there are chips inside at the ends of the cable.
There are converter chips at both ends. One takes the electrical signal from your computer and turns it into pulses of light, and the other turns that light back into an electrical signal for the display.
And usually, active electronics means you need, what, a USB plug? A power brick?
Some kind of external power injector, yeah. But this one doesn't have any of that.
So how does it power those chips over 164 feet of cable?
That's the most impressive part. It's an ultra-low power design. The chips just sip a tiny amount of current directly from the DisplayPort connector itself.
How tiny are we talking?
We're talking less than half a watt for each end. For an event professional, that is a huge deal.
It's one less thing to plug in, one less point of failure.
Exactly.
Yeah.
And one less safety hazard when you're running hundreds of feet of cable across a venue.
And that efficiency doesn't cut any corners on the signal quality, I assume.
Not at all. Think about all the features you need for 8K video. You have HTCP 1.4 and 2.2, which is the copyright handshake.
Right.
You've got HCR10, HLG, Dolby Vision for color, even high-end audio like Dolby True HD. If that digital handshake fails for even a millisecond over that distance, your screen goes black.
So this thing is built to be absolutely bulletproof, signal-wise.
Zero compromises.
Okay, let's switch to the other half of this then. The physical durability. Why does a high-speed fiber optic cable need to be built like a tank?
Because the sources are really clear.
Yeah.
This is purpose-built for rental and road applications.
The convention centers, concert stages, live broadcasts.
Yeah. Think about it. This gear is set up, torn down, shoved into a flight case, and maybe even dragged across a parking lot every single weekend. Glass fiber is, well, it's delicate, so it needs serious protection.
And the protection here is pretty extreme.
It starts with an integrated stainless steel corrugated tube. It's literally armor protecting the core.
Wow. Okay.
But you also have to protect the fibers from being stretched, not just crushed. And that's where they've added a layer of Kevlar reinforcement.
So you have high-strength fibers protecting the light-carrying glass fiber.
Right. And all of that is wrapped in a thick, tough jacket made of what's called TPU, or thermoplastic polyurethane.
So what does all that armor add up to? What are the strength readings?
This is what really brings it home. The short-term crush resistance is 2,000 newtons. That's 450 pounds of force.
450 pounds. So a fully loaded equipment case could roll right over this cable and the show just keeps going.
It doesn't stop. And then there's the tensile strength, how much you can pull on it. It's rated for 800 newtons, or about 180 pounds.
Which means when someone inevitably yanks it during teardown, it's not going to damage the cable or the 24-karat gold-plated connectors on the ends.
It's built for that reality. It's designed to survive its own users.
So to bring this all together for you, what we have here is a really stunning piece of engineering. It solves this impossible triangle of pairing Fragile, high-speed optical tech with brute force durability.
All while keeping that perfect signal integrity and somehow needing zero external power. It basically just removes distance as a problem for professional AV.
Yeah, it forces you to appreciate this blend of two completely opposite worlds, you know? High-speed, delicate optics and just raw physical strength working together.
Seamless.
And that raises an interesting thought for you to take away. The next time you're at a concert or a big corporate event and you see one of those massive high-definition video walls,
Mm-hmm.
think about what unseen layers of specialized, zero-compromise infrastructure like this armored cable are silently working underneath the stage to make sure that temporary high-definition experience looks absolutely seamless.